and welcome to this video on a problem solved using math. We have a committee of senators that consists of 4 people, Andres, Varo, Carolina, and Davis. We suppose that each member of the committee has 1 vote, and a simple majority is needed to pass or reject any measure. A measure that is neither passed nor rejected is considered to be blocked and will be voted on again. We want to determine 2 numbers, the number of ways a measure could pass and the number of ways a measure could be blocked. To solve this problem, I'm going to use sets, and there could be other ways of solving the same problem. If you know an alternative way, let me know. I will be happy to follow up with you. Let's focus on one thing at a time. Let's go with the number of ways a measure could be passed first. So here we write number of ways a measure could be passed. Now, based on the statement of the problem, we need a simple majority to pass a measure. We're not given any details on the measure, and those details don't really matter. All we need is a simple majority to get a measure to pass. We have 4 people in total. We get a simple majority if everybody votes yes, or if 3 people vote yes. So the scenarios we're thinking of are the ones in which 4 or 3 people vote yes for passing the measure. Now, to get 4 people voting yes, we just put everybody in a group. So we can think of Andres. I'm just going to write A, Varo, Carolina, and Davis voting. The order doesn't really matter. We're just thinking of the outcome of the voting procedure. We would put those people in a group, and they all vote yes, and that's one way of getting the measure to pass. So we're going to write this set of 4 elements that are actually people, Andres, Varo, Carolina, and Davis, in no particular order. So we could have written Carolina, Varo, Andres, Davis. Any combination is okay. The outcome is the same. We get one way in which the measure passes. Next, we get to work with 3 people at a time. Scenarios in which 3 people vote yes, 1 person votes no. So we need to choose 3 people among Andres, Varo, Carolina, and Davis. So for instance, we could go with Andres, Varo, and Carolina. That's the same as going with Carolina, Varo, and Andres, because the order doesn't really matter. It just counts as another way. So let's count it as a second way. And somebody else could say, okay, let's just go with Varo, Carolina, and Davis instead. Or any other combination of those same letters, B, C, and D, that give us exactly the same set, because sets don't really care about the order of the elements. So this is a third way. And we could go with other combinations too. As we think about other combinations, we're thinking about ways of choosing 3 people out of 4. So for instance, we could go with Andres, Carolina, and David. That's a different configuration. And then I think that's all the combinations we have. We're probably missing one of them. Let's see, we have Andres, Varo, Carolina, Varo, Carolina, Davis, Andres, Carolina, Davis. I think we're missing the one in which C is not there. Carolina is not there. So Andres, Varo, and David. There you go. And there we have a fifth way in which the outcome is that the measure passes. What we have listed are subsets of 3 or 4 elements of the set A, B, C, and D. There are 1, 2, 3, 4, 5 of those subsets, so we can say that there are 5 ways in which a measure could be passed. So the answer is there are 5 ways in which a measure could be passed. All right. Okay. Now, we're going to move on and talk about the number of measures, the number of ways in which a measure could be blocked. Okay, so let's erase this right here. I'm just going to work with blocking the measure. So this is gone. We're thinking of a totally different situation. We're still going to use sets. Okay. Now, if there is a simple majority, we get pass or reject. A measure that is neither passed nor rejected is considered to be blocked. And that's what we want to get, a measure that is blocked. To get a measure blocked, we need to avoid having a majority. There will be a tie. And to get a tie, we need 2 people to vote yes and 2 people to vote no. So in this case, we're thinking of selecting 2 people out of the crowd, and the other 2 will vote no. So in this situation, let's just work with the first situation. Let's say Andres votes yes, Varo votes yes, Carolina votes no, and David votes no. We can assign this scenario to the set right here, A, B. Suppose we consider the set of people that vote yes. And we will have Andres and Varo in the same set. The other 2 are outside of that set. That's one possible way of getting the measure blocked. Now we can think of another 2 people voting yes. So for instance, Andres votes yes, Varo votes no, Carolina votes yes, and Davis votes no. We would get the set A, C, the set of people that vote yes. And we continue like this in a very similar way. We're going to get a few possibilities. We have A, B, A, C. Now when A is not there, we could think of B, C, or B, D. And finally, when C is not there, we could think of, we also have A, D, yeah. That's when C is not there. A, B, A, C, A, D, B, C, B, D, A, D. I think we're missing C, D. Yes, there you go. 1, 2, 3, 4, 5, 6 scenarios. So there are 6 ways in which a measure gets blocked. Okay, so we conclude that there are 5 ways in which a measure could be passed and 6 ways in which a measure could be blocked. Now notice that if the number of people changes, then the answers change, and then it gets really cumbersome to list absolutely every subset and to count the number of ways in which a measure could be passed or could be blocked. So for solving this problem in a much realistic scenario, in which we have far more people, we would actually need to work with some combinatorics. So we're not going to go there, but here we have a way to use sets to solve this problem. Right, thank you for watching this video. If you have questions, let me know. Bye-bye.